Hi guys, hope everyone's doing well. If you notice the picture on the screen, this is a safety who used to play for the Steelers. His name was Ryan Clark. He was a pretty good player, went to the Pro Bowl. However, in Pittsburgh, he's most noted as the person who was unable to play in the playoffs at Denver. Now, I don't know about you, but you have a job right now, and your job is to get through school so that way you can go to college, and then that would be your job then. And then after that, you actually go into the work world and get a real full-time rest of your life job. Now, Ryan Clark, football was his real job. However, the Pittsburgh Steelers, whenever he was unable to play at Denver, were like, all right, that's fine, take the day off. I don't know about you, but I feel like my job would be a little less understanding than this. But this is because Ryan Clark actually had a medical condition called sickle cell anemia. Now, what is sickle cell anemia? Kind of just as it sounds, your red blood cells actually are sickle shaped, as you see there on the right. They almost look like a piece of the moon whenever it's not quite completely full. What happens with sickle cell anemia is you have normal red blood cells and they carry oxygen to your body. Anytime you perform any type of physical activity, whether it's running, weightlifting, playing sports, anything like that, you need oxygen throughout your whole body to keep your muscles working. The sickle red blood cells, what they do is they actually prevent these healthy, normal-looking red blood cells from carrying oxygen to your body. For instance, say you're at the gym and you're working your legs out and you're doing squats one day and you have sickle cell anemia. What'll happen is those sickle cells will actually get in your blood cells and block the flow of your normal red blood cells that are carrying that healthy oxygen to your legs. So what'll happen is your legs, obviously, are not going to get that oxygen. Therefore, you can't get a healthy supply of blood to that area, and your legs will pretty much give out, stop working. Ryan Clark was unable to play at this stadium, Denver Broncos Stadium, also called Mile High Stadium, and this is because it was, again, called Mile High Stadium. It's a higher altitude than what we're used to here in Pittsburgh, so there's not going to be as much oxygen concentration in the air. So with his sickle cell anemia, with preventing oxygen from getting to the rest of his body at a normal rate which we go, he's also combating that mile high, that low concentration of oxygen in the air at this stadium as well. So he was unable to play for obvious health reasons. However, I got a different example for you guys. If you've ever seen one of these masks, no, it's not Bane from Dark Knight Rises, but it's called a high altitude training mask. And what these high altitude training masks do is literally almost make it feel like you are at Mile High Stadium or even higher than that. And they actually limit the amount of oxygen going to your body. To me, that doesn't seem something like you'd want to do. Hey, I need oxygen to breathe, so what am I going to do? Limit it. Doesn't really make a lot of sense. But the theory behind them is that by exposing an athlete to an environment that is low in oxygen, so in other words, the concentration of oxygen is much lower than regular, your body will eventually adapt to this stress of not getting a lot of oxygen and actually be more efficient at transporting and using oxygen. This was one of the things that Lance Armstrong said he used whenever he was cycling in order to make his oxygen in his body more efficient. You can buy these. They just actually made a second version a little bit ago. And this version actually limits further the amount of oxygen going to your body. So when you're using one of these, you really gotta breathe hard to get oxygen in, but you're still not getting that amount of oxygen in. I was watching a show one time on TV. It was called True Stories of the ER, I think. And the one guy working out was in so much pain coming into the ER, and they found out that it was actually because of one of these masks. He was trying to breathe in so hard that his lung actually collapsed, and they had to stick a gigantic needle in his body to get some of the air out and get his lung back to normal. So would I use it? I don't think so. I highly discourage you from trying this too. In theory, they would work, but people just take them a little bit too far and try to really get their bodies in tip-top shape and really use that oxygen, but the side effects are really immense and you can actually end up dying from them. So how does all of this relate today? So today I just wanted to do a real quick introduction to something called STP. Now, with the high altitude training mask, obviously the amount of pressure you have to use to take in that oxygen is going to be really high when you have one of those masks on. That's what I wanted to relate to today. So standard pressure on the Earth is 1 atmosphere, and that's the unit of measurement that we use. There's also another one that I want you guys to know called kilopascals. That stands for kPa, and that's 101.3 kilopascals are in 1 atmosphere. So this is just the standard unit of pressure. Also, standard unit of temperature, degrees Celsius, and at STP, in order for standard temperature and pressure to be there, the temperature has to be at 0 degrees Celsius and the pressure has to be 1 atmosphere. So whenever we talk about something being at STP, all we're referring to is that the temperature is at 0 degrees Celsius and the pressure is at 1 atmosphere. So instead of saying, 50 million times, hey, the temperature is 0 degrees Celsius, the pressure is at 1 atmosphere, we just say it's at STP. All right. So what we're going to do next is we're going to relate this STP to volume in the mole that we talked about last week. So, STP conversion factor. 1 mole is 22.4 liters. This sounds pretty easy, but if you think about it, right now you should be saying, wait, this doesn't really make sense because I know whenever I have solids that 1 mole of one substance is probably going to take up more space than a mole of another substance because some of the atoms are a little bit bigger than the others. And I agree with you 100%. So that's why this rule only applies to gases like hydrogen gas, helium gas, oxygen gas, these types of gases. So whenever we're talking about gases, we can use this conversion factor of 1 mole equals 22.4 liters. Lastly, this is what we're going to apply tomorrow. If going from moles to volume, you multiply the moles by 22.4 using that conversion factor. And then lastly, if going from volume to moles, you divide the volume by 22.4. All right, so we're going to go over a few more examples with you tomorrow. Hopefully you learned something today, mostly about sickle cell anemia and high altitude training, the effects that they can have on someone. So anyway, have a good night, guys.